All right, so we are going to be doing predictions with proportions. If you printed this out, my printer was being weird and it wouldn't make it front and back, so I just had to kind of tape my papers together, and then you fold it in half, and then I suggest cutting on the dotted line or the straight line on the inside because my dotted lines didn't match up perfect, so that's what I decided to do. So, as it says on the side here, we're going to now make predictions with proportions. In case you forgot what a proportion is a proportion has two equivalent ratios or two equivalent fractions. When we're setting this up, this first side, this is the information that we know. It can be your theoretical, or it could be your experimental probability. It just depends on what they give you in the problem. The fraction on the left is what you know. It's your theoretical or your experimental probability. And then the fraction on the right, that's what you're trying to predict. Oh my goodness, I messed up. That's what you're trying to predict on the left side. So you need to fill in with those numbers from what you know and what you're trying to predict. Okay. So there's a few reasons why we predict. Sometimes people predict because it takes too much time. Sometimes you want to do something a lot and just it takes way too much time to go around and maybe survey the whole school as opposed to just surveying the 7th grade math students. Sometimes we predict because it's going to take too much time. Sometimes we predict because we don't have enough resources. Maybe we don't have enough people to go out and do a survey of the whole United States. So what we want to do is we'll just ask, survey some people in our state. Might have enough money for it, and yeah. People also sometimes like to predict to help with a business. I used to work at Jimmy John's, the sandwich shop, and every day we would predict how many sandwiches we thought we were going to sell based on what we had sold in the past, because we don't have time to, okay, everybody who's going to come to our Jimmy John's today, tell us what you want so we can make sure we have enough meat cut, enough lettuce, enough tomatoes. We guess how much we think we're going to need, and hopefully that will match what we'll need in the future. Or business, maybe you need to order some parts based off of what people have purchased in the past. There's other reasons why we predict, but those are just a few examples. So let's get into this first scenario. Don't forget, we got to keep in mind this proportion. This first scenario says Sam is going to roll a dice 120 times. Using a proportion, make a prediction of how many times he will roll a 1. It's going to take a long time to sit there and roll a dice 120 times. It's going to take too much time. So what you can do is you can predict. Remember this side, this is what we know. And in this situation, is this 1/6, is that the theoretical or is that the experimental probability? That's theoretical. It's theoretical because that's what we expect. Sam hasn't done anything yet. When Sam actually keeps track of what he rolls, that would be experimental probability. Theoretical, remember, that's what we expect. And then this side again, that's what we're trying to predict. So for us to go ahead and solve this, now we're going to need to butterfly multiply. So I'm going to take, what's 1 times 20? 120. 120. I'm going to set that equal to 6 times x. We don't know what x is yet, so we just have to do 6x. And then to solve, use inverse operations, our river of love. 6 times x, the opposite is divide by 6. To solve for x, what's 120 divided by 6? 20. So x would equal 20. We would predict that he would roll a 1 20 times. And that's it. The most important thing is making sure that you've got the right proportion set up. Let's do our second scenario. Our second scenario says Pam is flipping a penny 324 times. Again, why would you do it that many times? Let's do a prediction instead. Pam is flipping a penny 324 times. How many times can you predict she will land on tails? So for this side, we need to put in what we know. Has she done an experiment yet? Not yet. Not yet. So we need to have the theoretical probability. What is the theoretical probability of her flipping tails? If you haven't seen this yet, this P means probability, and what's on the inside, that's what you're looking for. So this reads the probability of flipping tails. What is the theoretical probability of flipping tails on a coin? It is 1 out of 2, because on our coin, we have the head side, and then we have the side with the bird on it, if it's the quarter. The tail side, that's the side with the quarter. Now on this side, again, this is what we're trying to predict. We know that she's going to flip it 324 times. Is that 324 going to go on the top or on the bottom? It's going to go on the bottom because that's how many times total she's going to flip it. We want to figure out how many times out of 324 it's going to be tails. Nice job setting that up. So now we cross multiply. Go ahead, pause the video and solve that for me on your own. We would predict that Pam would flip tails 162 times. All right, we've got one more scenario. This time we've got a spinner. So it says Cam is spinning a 4-part spinner labeled red, green, blue, and yellow. So that's what they're showing you up here. We've got our blue, we've got our red. Oh, this one is different, I lied. So it's blue, red, green, yellow, not orange. This is yellow. There's our spinner. It says if he spins 200 times, how many times is he likely to spin a red, blue, or green? Again, we've got to start off with our proportion. Pause the video, see if you can fill out this whole proportion on your own. When you're done filling in the proportion, play the video just to check to make sure that you're on the right track. This side we know. So red, blue, or green. If I look at my spinner, there is 1, 2, 3 of those colors out of 4 total. So my probability of spinning one of those numbers would be 3 out of 4. And we're trying to predict how many times out of 200 total spins. If you need to fix that, go ahead and make those corrections as you need to. But if you got that set up correctly, go ahead, pause the video and solve it do that whole prediction for me how many times you think it'll be red, blue, or green. Okay, so after you do the math, you should see that Cam would expect to spin red, blue, or green 150 times. Remember, that's out of a total 200 times. Hopefully that helps you guys with your making predictions. As always, if you have questions, please email us. We'd be more than happy to help you.